Lesson 4.1, Powers and Exponents. The vocabulary to go along with it is an exponent is the number of times the base is being repeated. So 5 to the third power, the 3 is the exponent, where the 5 is being repeated 3 times. The power is a number that is expressed using exponents. So 5 to the third power is your power, and this is how you would write your power. Large 5 and then a little 3 is your exponent. A base is the factor that is being repeated. So in this example here, your 5 is the base and it's being repeated 3 times, and that is your exponent. Standard form is when a number does not contain any exponents. So 5 to the third power contains exponents. Take it out of using exponents and it's 5 times 5 times 5. Standard form is 125. So our notes for 1 on powers and exponents. Our objective is to write expressions using exponents, and we're going to evaluate expressions containing exponents. Our Common Core state standards are 8EE1, and our mathematical practices we'll look at is 1, 3, 4, 6, and 8. So the first thing is the expression 2 times 2 times 2 times 2 can be written as a power. Each of those 2's are your factors. So in the table, we have the powers, how you read it in words, and as repeated factors, and we are going to fill in what it's equal to. So the first one, it is read as 2 to the 0 power. 2 to the 0 power is defined to be 1. I will go over the reason why it's 1 at the end of filling in the table. 2 to the first power, which means that the 2 is being repeated 1 time, so that is 2. The third one is read as 2 to the second power, or 2 squared. So our 2 is being repeated 2 times, so it's 2 times 2, which is equal to 4. The next one is 2 to the third power, or could be read as 2 cubed, which means your base of 2 is being repeated 3 times, which is equal to 8. Next one is 2 to the fourth power, which our base is being repeated 4 times, so it's equal to 16. Now, why is 2 to the 0 power equal to 1? It says that any number except 0 raised to the 0 power is defined to be 1. 1 to the 0 power is 1, 2 to the 0 power is 1, 3 to the 0 power is 1, x to the 0 power is 1 as long as x is not equal to 0. So if we look at the pattern of powers of 2, you can see that if we have 1, we multiply it by 2 to give you 2. 2, multiply that to 2 to give you 4. 4, multiply it to 2 to give you 8, and 8, multiply it by 2 to give you 16. If you work backwards, you would divide 16 by 2 to give you 8. 8 divided by 2 gives you 4. 4 divided by 2 gives you 2. And what is 2 divided by 2? That is equal to 1. Okay, so there's our proof that any number raised to the 0 power is equal to 1. Next example. When you have powers with negative bases, it says when you have a negative number as a base, you need to write it in parentheses. And I have 2 examples that shows it with parentheses and without parentheses. So in the first example, it says in parentheses, negative 9 to the second power. That means your base is negative 9. That is what's being repeated 2 times. So negative 9 times negative 9 is 81, because 2 negatives gives you a positive. The next one is negative 2 to the third power. So that means your negative 2 is being repeated 3 times. So 2 times 2 times 2 is 8. 3 negatives gives you a negative 8. There's a difference if you do not put the negative in parentheses. So that means where it says this negative 9 to the second power, it really means the opposite of your 9 squared. So that means you're taking the opposite of 9 times 9. So that gives you a negative 81. So be careful whenever there is a parentheses around the negative, that means your whole base is negative. If there's no parentheses around it, it's only the number right before it, not including your negative, being repeated. So in our next example, we're just going to write these using exponents. So our 3 is being repeated 3 times, so it's 3 is your base, and it's being repeated 3 times, so it's 3 to the third power. Number 2, your x is being repeated 4 times, so it's x to the 4th. In number 3, we have a 2. You don't need to put the a with the multiplication because 2 touching a means to multiply, and you have 2 a's, so it's a to the 2nd power, a squared. Times your b, you don't need the multiplication sign at all, and it's b to the 3rd power because there are 3 b's. Number 4 is -5 times -5. Because the negative is in parentheses, keep it in parentheses. How many 5s are being repeated? 2. So it's -5 to the 2nd power. Number 5 says x plus 1 times x plus 1 times x plus 1. Our x plus 1 in parentheses is what's being repeated 3 times. So it should be x plus 1 in parentheses to the 3rd power. Evaluate each expression. We're going to find the value. Remember to use PEMDAS, the order of operations. So the first thing we can do for number 1 is take it out of exponent form. So it would be 5 times 5 times 5. Well, 5 times 5 is 25. Bring down the 5, and 25 times 5 gives you 125. Number 2, we have our -7 in parentheses, so it's -7 times a -7, which gives you a positive 49. Number 3 is 4 to the 3rd power, so our 4 is being repeated 3 times. 4 times 4 is 16, and 16 times 4 is 64. In example 4, we have our -2 in parentheses, but we also have the power in parentheses. So that means take the opposite of 2 times 2 times 2 times, now in the second part it says -5 and then to the 2nd power, and the 2 is outside the parentheses. So that means that it would be -5 times -5. So now we have to finish our evaluating, and 2 times 2 times 2 is 8, and then take the opposite of that, that's -8, and then -5 times -5 is positive 25. Negative times a positive is a negative, and 8 times 5 is 200, so it's -200. Number 5, we do inside the parentheses first, so it's 2 times 3, which is 6, and that's 6 to the 2nd power, so it's 6 times 6, which is equal to 36. The last example is 2 to the 2nd power, so it's 2 times 2, times 3 to the 2nd power, so 3 times 3. 2 times 2 is 4, and 3 times 3 is 9. You could also go from left to right, and 9 times 4 is 36. In the next examples, we have to do inside the parentheses first. So 4 divided by 2 is 2 to the 3rd power. 2 to the 3rd power means 2 times 2 times 2, which is 8. At this point, if you know what 4 to the 3rd power is, you do not have to show 4 times 4 times 4, because 4 to the 3rd power is 64. And 2 to the 3rd power, we can see from the previous answer, is 8. So 64 divided by 8 is 8. So this is 4 times 4 times 4, and this is 2 times 2 times 2. Number 9 says 5 to the 2nd power minus 3 to the 2nd power. 5 to the 2nd power is 5 times 5, or 25, minus 3 to the 2nd power, which is 3 times 3, or 9. And 25 minus 9 is 16. Again, if you need to write off to the side what 5 times 5 is and 3 times 3 is, you can, like the previous page, or you can just put the evaluated answer. Evaluate each expression, remember PEMDAS. So we are substituting in for the value of the variable and then solving by using the order of operations. So for the first example, we're substituting in -3 in for y. Since it's negative, keep it in parentheses. So it's -3 in parentheses to the 3rd power, which means -3 times -3 times -3. 3 negatives gives you a negative answer. 3 times 3 is 9, times 3, which gives you a positive 9 times a negative 3 to give you a negative 27. Number 2 says x to the third power plus 6 if x is 3. Substitute the 3 in for the x. So it's 3 to the third power plus 6. 3 to the third power means 3 times 3 times 3 plus 6. 3 times 3 is 9, and 9 times 3 is 27. So it's 27 plus 6, which is equal to 33. Example number 3. Start by substituting in your negative 3 in for your x. So it's 3 times, in parentheses, negative 3 plus 1 for your y to the fourth power. Order of operations says you have to do inside the parentheses first. So it's 3 times negative 3 plus 1. Take the sign of the larger and subtract. So it's negative 2 to the fourth power. Since the negative 2 is in parentheses, that means it's 3 times negative 2 times negative 2 times negative 2 times negative 2. The negative 2 is being repeated 4 times. Since there are 4 negatives, our answer is going to be positive. So, our 4 negative 2's equal a positive 16. 3 times 16 gives you 48. Since multiplication is commutative, you can change the order of your multiplication. Next example is a to the second power plus 3a minus 1. So we have to substitute in 2 for both of the a's. So it's 2 to the second power plus 3 times 2 minus 1. Order of operations, do your exponents first. 2 to the second power is 4 plus 2 times 3, which is 6, minus 1. Addition first, so it's 10 minus 1 to give you 9. Last example on the page, we have 2 times, in parentheses, a minus b to the second power minus c to the third power. If a is 2, b is negative 3, and c is 4. So we have to substitute in for our a, b, and c. So it's 2 times, in parentheses, 2 minus a negative 3 to the second power minus c, which is 4 to the third power. First, change subtraction to add in the opposite. Then do inside the parentheses. So it's 2 times 5 to the second power minus, we can also do the 4 to the third power, which is 64. Next, we need to take 5 to the second power. 5 to the second power is 25. So it's 2 times 25 minus 64. Next, we have to do multiplication. So it's 2 times 5, and I'm going to slide it off to the side, which is 50, minus 64. It's a subtraction problem, so we have to change it to add in the opposite. Now, different signs, take the sign of the larger number and subtract 64 minus 50 to give you negative 14. Okay, last example in the notes. Problem solving with exponents. The playing area for beach volleyball includes the playing court and the free zone. Evaluate each expression to find the area of the playing court and the free zone. The playing court is a rectangle with an area of 2 to the 7th power square meters. To find the area of it, 2 to the 7th power means 2 times 2 times 2 times 2 times 2 times 2 times 2. We can multiply them in groups of 2 or 3, so that's 4, 4, 4 times 2. Then 4 times 4 is 16, and we can do 4 times 2 is 8, and 16 times 8 gives you 128 meters squared. The area of the free zone is 2 to the second power times 3 to the second power times 5. So 2 to the second power times 3 to the second power times 5. 2 to the second power is 4. 3 to the second power is 9, and then 5. Again, you could change the order and group them together. I'm going to multiply these mentally easy. So I'm going to multiply the 4 times 5 together to give me 20 times 9 That gives me 180 meters squared. You could go from left to right and do 4 times 9, which is 36, and 36 times 5 is 180.